Where did the solar system come from? When the solar system formed, there were no people to observe how it was made. Observe means to watch something happening. So how do we know what happened? Scientists can try to solve a problem like this in two different ways. They can look for evidence in the form of facts from observations or experiments to support their theory, and then try to explain what they have found. They can think of a testable theory, called an hypothesis, and then look for evidence to support the hypothesis. Here are some facts about the solar system. All the planets in the solar system follow a path or orbit around the Sun in the same direction. The Sun and all the planets, except Venus and Uranus, spin on their axes in the same direction. Most of the moons of the planets orbit their planets in the same direction as the planets rotate around the Sun. Scientists can see distant stars forming in other parts of space. These stars are being formed from clouds of dust and gas. A cloud of dust and gas in space is called a nebula. The picture shows one of these clouds of dust and gas. You can see the young stars in the cloud. Some young stars can also be seen with a flat disk of dust around them. Scientists think our solar system was formed this way. Scientists cannot observe a star or solar system forming in an experiment. Instead, they use computers to create models. A model is a way of representing something that is difficult to observe directly. The scientist put many of the known laws of physics into a computer program. Then the computer uses this information to predict what will happen, starting with a cloud of dust and gas. The result is a prediction that a star will form surrounded by planets. How do stars and planets form out of dust and gas? The picture shows what scientists think our solar system looked like as it was forming. You saw in section 3.1 that any object can act as a source of gravity. All the particles of dust and gas in the pictures have their own weak gravity. The particles of dust and gas pull on each other with very weak forces due to their own gravity. As they stick together, their total mass increases. As their mass increases, so does the strength of their gravity. That means they attract more dust and gas with a stronger force. This starts to form a small ball. Gradually, this ball gets bigger. If the ball gets beyond a certain size, it will get hot enough to become a star. Otherwise, it will become a planet. Most of the facts about the solar system support or agree with this hypothesis. The fact that Venus spins on its axis in the opposite way to all the other planets seems to contradict this hypothesis. Contradict is the opposite of support. It means to go against something. This is how our solar system may have looked 4.6 billion years ago. Scientists think the planet Jupiter almost reached the size to be a star. It takes millions of years to form a star or a planet. Scientists use both observations and computer models to test ideas about how the solar system formed. They compare facts with model predictions to see what fits best. The matching directions of orbits and spins support the idea that everything formed from a single rotating cloud. Gravity and rotation naturally lead to a flattened disk and aligned motions. Exceptions like Venus and Uranus give clues about later collisions or special events. Scientists use exceptions to refine their theories. So, although no one watched the solar system form, scientists piece together the story using facts, observations, and models. Most evidence supports the idea that our system formed from a rotating cloud of dust and gas. And scientists keep testing and improving ideas as they gather more data. Remember, science uses evidence and testable ideas to explain how things like the solar system came to be. Explore nebula images and simulations to see these ideas in action. Thanks for watching.